Good afternoon, all of you. In today's session of class 9 physics, we are going to continue with Newton's laws of motion. And in fact, the topic for today's session is Newton's first law of motion. That is the topic for today's session. Now, what happened was that before the time of Galileo was a predecessor of Newton. So before the time of Galileo, it was believed that if a body is moving, then a force is necessary to keep the body in motion. Before the time of Newton, there was Galileo, and before Galileo, for many centuries, the scientists believed that if a body has to be in motion, any kind of motion, uniform motion, accelerated motion, any kind of motion, if a body is in motion, then definitely a force has to be there. So it was a belief for many centuries up to the time of Galileo. But Galileo was the first person, and then Newton later on made it into a law, who said that you don't need a force to keep a body in motion. So what Galileo and Newton said was, if a body is in a state of motion and you don't put any force on it, then it will continue in the same state. So say a body has a velocity of 5 meters per second. If you don't exert any force on it, the body will continue to move with a velocity of 5 meters per second in the same straight line and same direction as it was moving. So according to Galileo and Newton, the belief that a force is compulsory for any motion is totally unjustified, right? And this was a very important discovery or important law given by Galileo and Newton, that you only need a force when you want to change the state of rest or motion of a body. Otherwise, there is no need of a force, right? So suppose a body is at rest and you want to make the body move, then you require a force. Suppose a body is already moving, let's say with a velocity, say 10 meters per second, but you don't want the velocity to be 10 meters per second, you want the velocity to be something more or something less, then you will have to exert a force. So force is that physical entity which changes the state of rest or motion of a body. According to Newton and Galileo, this was the fundamental difference with what the previous centuries all the scientists were saying. So that means what? That every body, unless you exert a force on it, will tend to remain in its original state. So if a body is at rest, it will tend to remain at rest. So the tendency to remain at rest is called inertia of rest. And if a body is having a motion, it will tend to continue with the same motion. And the tendency to continue with the same motion is called inertia of motion. So inertia of rest is basically that the body is at rest and tries to continue to be at rest, and inertia of motion is that the body is in motion and it tends to continue in that same motion as it was earlier. So suppose if a body is having a velocity of 5 meters per second, so unless you exert a force, it will continue with the velocity of 5 meters per second. That means it will continue to move in the same direction with the same speed of 5 meters per second, unless you exert a force. If a body is at rest, unless you exert a force, it will try to remain like this. So this is Newton's first law, and it was originally stated by Galileo, but Newton made it into a law, right? So the tendency of a body to remain in a state of rest is called inertia of rest. The tendency of a body to remain in the state of uniform motion is called inertia of motion, right? So these are the two types of inertia of a body. And what exactly does this inertia depend on? What does this inertia depend on? So inertia depends on mass. So inertia depends on mass, right? The inertia of a body depends on mass. So if you have a body with a huge mass, then it will have greater inertia, right? If a body has a very large mass, it will have greater inertia. And if a body has a very small mass, it will have smaller inertia, right? Like, just let us take a simple example. If you have a small pebble, on the ground, then to make the pebble move, what do you have to do? You just give it a gentle kick. Just give it a gentle kick and it will move. But মানে 2 মিনিট পরে টাকা। So if you want the small stone to move, then you just have to give a gentle kick. But if you want this huge boulder to move, then you will have to push it with all your strength. So greater mass means greater inertia, smaller mass means smaller inertia, right? So similarly, suppose if there is a small piece of stone and it's moving, so to stop it you don't have to provide much strength. But suppose if a huge rock is moving, then to stop it you will have to provide an enormous strength. So this is what Sir Isaac Newton said, that the mass of the body gives you a measure of the inertia. If the mass is more, the inertia will be more. And there are two types of inertia. Inertia of rest, that is the body was at rest and wants to continue to be at rest. And uniform motion, that is the body had a certain velocity and wants to continue with the same velocity. So this is the topic, Newton's first law, and based on this I'll give you some homework. Okay, so this is the homework. I am giving you two examples of inertia. So out of these two, you have to identify which one is inertia of rest and which one is inertia of motion. So number one, when a train suddenly starts moving forward, the passenger in the compartment tends to fall backward. Number two, when a passenger jumps out of a moving train, he falls down. So these are two examples of inertia. What you will have to do is you will have to look at these two examples and identify that which is inertia of rest and which is inertia of motion, and this will be your homework for the next day. So that will be all, and I'll end the session now. Bye all of you.